All right, welcome to C++ Chapter 2. I have a short amount of time, so I'm going to go through this a little bit fast so I can get it out to you before late Tuesday night. If that doesn't work, I'll write it again. We're going to cover Chapter 1, Types, Variables, and the Standard I.O. For the Lost Fortune program at the end of the chapter. Hopefully, you've already gone through and done all of the code in this chapter, read it, and understood it, and we're all good. You can do the assignment with no problem. But for right now, I'm going to cover it, what it talks about. So the first step is why C++? Well, it's fast. It's very low level. It lets us deal with RAM directly. It deals with the memory of the computer instead of having an intermediary there. It's flexible, which means it can do many different things. And it is well supported because it's been in use for a long time because it's a good program. We're going to deal with a lot of errors. I will practice errors. Let's go ahead and, at the beginning of every assignment, I would like you to put your name, the name of the class, C++ is fine, and then what chapter we're working on. And then underneath, if you want to, and this is what I'm going to do, I'm going to build a block comment, which looks like that. And I'm going to put the things that I want to talk about. So I want to show off how to read errors. What else do I want to talk about? Writing your first C++ program, including comments. These are comments, by the way. You can create a comment by double slash. And anything after that double slash is ignored. So for example, if I wanted to say, what is the using namespace for, I would say, this is so I don't have to type std : at all. This is required for strings. This is required for cout and cin, and probably some other things. So these guys are preprocessor directives. This is the actual start of your program. When the compiler adds all these together, it knows what it needs to run your program, and then it says, all right, I'm going to start at int main line here. Okay, say something to the console. Here it is in the console. And then return 0. We're done with that function. And then we're done with the whole program. So, comments. Let's talk about, the computer doesn't care about white space. So if we wanted to, we could build the entire program like this. And it should run. Let's try. Yep, there you go. I just recompiled it. Here's the entire program. I don't need any white space, except it's harder to read and it's harder to fix errors. And so we use white space, including tabs, including spaces occasionally. So be nice to me and make your program easy for me to read so that if you have errors, I can help you fix them so that I can grade this better. Make sure you're tabbing anytime there is a curly brace. This is called a curly brace. And anytime you have one, everything underneath it should be tabbed. So if we had, say, an if statement, which we'll learn about later, if true, then we'll have another curly brace. And you see my compiler automatically tabs it down. Cout, always tab. So if we ran that, we'd get always tab because this if statement is true. Unrelated. Including other files. So this IO stream is another script somewhere. It's another file somewhere, and so is string, and so is namespace. So if you think of this line in terms of a sentence, sentences always end with punctuation, usually a period. This semicolon is the period of your program, and if you leave it out, you will get an error because it will not expect this next if statement. It will expect an end of the program. And so let's practice our debugging right now. Hello CPP, this is the file that has the error. Line 18, so here, line 18, this is the error. Wait a second, this letter is fine. This line is fine. It says syntax error, missing semicolon before if. Well, if is the first thing on this line, so most of the time if this line is true, go to the line directly above it. And there's the semicolon that we missed. Oftentimes, you'll create a code block, which is anything between these curly braces, and you'll forget to close it. And this is another common error that you'll get. I'll compile this again, and it'll say, hello CPP, line 16, fatal error. The left brace was unmatched at the end of the file. So line 16, this guy, was opened, and then this guy was opened, and you see my computer thinks that it was closed here, and therefore my computer program was never closed. So we replace the brace, the curly brace, and we're ready to go again. Now we'll deal with this more later, but this return 0 is A, not required, but it is a good thing to have and expect to have. It's called a return value. And anytime a function has a, what do you call it? A return type, this function, for example, int main, returns a type of int, which is a number, a whole number. And so we're returning a 0, which means in this case that everything's fine. Some programs will have different return types, and then really robust programs will have error codes so that if something horrible happens, see out, oh no, an error. And then what they'll do is they'll return 404. And so cout, the program runs fine. Make sure you got punctuation in there just because. So if we compile this and then run it, it'll say, oh no, an error. And then it will end the program. We'll never get to this line here because this return statement kicked us out of our int main function, and then the program ended. And then we could say, 404, website not found. These aren't the droids you're looking for. And so on. So these are return statements. They're returning an integer because the return type of this function is int. We don't technically need it, but we're going to leave it in because it's a good practice. So in the second program, the Game Over 2.0 program, they include the using namespace, and we don't have to type std::: anymore, and that's great. We're going to use that for the rest of the rest of the book. There's another way to do this, and so the reason that you leave it out, the reason that you would do something like this, using std::cout and using std::: end line, is because we're saying, hey, I only need to use this stuff, the functions related to cout and the functions related to end line, don't include any extra bloat in our program at all. Make it as small and as lean as possible, as few lines of code. And so because we can cut out as much as possible out of C++ and our programs will run faster because they don't have things like cin, character in, or I don't know, God knows all the other things that are included in the std namespace. So we can do it this way and we'd be fine, but I'm just going to know that I want to always use using namespace std. I'm not worried about the size of my program. If we were to navigate to my documents and Spring 2018, here's my application at 181 kilobytes. Here's my source code at 1 kilobyte, the C++ file. The actual compiled program is 181 kilobytes, and I believe that this OBJ file is also required at 67 kilobytes. So when you need the speed, when you need the small size, or even when you just want it, you're welcome to use the smaller std : or just write it into your code every time to keep things small and simple. So let's talk about adding things, making our computer an expensive calculator. So let's go ahead and make this false so that this doesn't run anymore. And we can move on to arithmetic. So our ship was hit with a laser. We've sustained 40 damage. Our health, let's end that there and say cout. Our health is now, we can say 400. Maybe it's a big ship, right? Maybe it's a small ship. 100 minus 40 is equal, well, that'll equal 60. And we can just add a period at the end and say new line. So let's see what that does. Compile and run. Our ship was hit with a laser. We've sustained 40 damage. Our health is now 60. The program runs fine. Okay, we can do the same for cout. Our mechanics have repaired half of the damage. Our health is now cout. Let's do it there. So why am I not writing directly out of the book? Because that would be boring. You already have the book for that. I like to write my own stories, make this more fun. You're welcome to do this or leave it simple as you want, if that's what helps you learn better. It helps me learn better when I have a story. Our health is now 60 plus 20. And there's the period, and there's the new line. This \n is the same as end line. It just goes to a new line. If I had 3 of them, and they need to be inside the quotes here, then I would go down. I would enter a new line 4 times, and there would be a bunch of white space. So we can demonstrate that here. Compile and run. Our health is now 80. 1 new line, 2nd new line, 3rd new line, 4th new line, and then the program runs fine. Okay, so we're all familiar with addition and subtraction. We're probably familiar with multiplication. Come on. There we go. One you might not know about is called the modulus operator. And the modulus operator gives us the remainder of a division problem. So if we said dividing their ships into groups for our attack team. See out. How many ships do you think there are? Let's say there's 22 ships. And we have 3 attack wings. There is, and this is where we'll do our modulus to find the remainder. So 22 divided by 3, and we'll use the modulus here, modulus 3. Ships, we'll put this in parentheses, remaining. So let's see what that gives us. Dividing their ships into groups for our attack team, 22 ships, we have 3 attack wings. There is 1 ship remaining. Forgot that space right there. So this, 21 divided by 7 divides evenly, leaving 1 left over. And so that's modulus. It's a really, really great way to have any random number divided by, let's say, 6. And let's say that random number is 27,832, and we divide it by 6. Well, it's going to give us a number that's either perfectly right, so there's no remainder, and that's a 0, or it'll give us a 1 or a 2 or a 3 or a 4 or a 5. And then we can add 1 to that number, and what we get is a die, 6-sided die. 6-sided die, because it'll give us a number between 1 and 6. So we'll use modulus later when we're practicing random numbers, when we're practicing die, rolling, and other things. It says in the book that you can also use parentheses to add things first. 7 plus 3, or 2, times 12 equals, whatever. We can just see out that. There you go, 108. So 7 plus 2 is 9. 9 times 12 is 108. We can also multiply decimal numbers. The modulus operator is the important one here. If you understand all the other math in the book, then we're fine. So it looks like that's all the time I'm going to have in this video. I will pick it back up with the game stats program in the next video.